Hi all. So in this lecture, we will study what is Boolean algebra, what are logic gates, what are Boolean functions. But before we start Boolean algebra, we need the knowledge of decimal and binary number system. This knowledge we need decimal and binary number system. In this lecture, first, first let's have some knowledge of decimal and binary number system. Let's start with the number system. Actually, number system is a separate topic. So after Boolean algebra and minimization, we will study number system in very detailed manner. Okay. So right now, let's just focus on two number system. Those are decimal number system and binary number system. Let's focus on this. So what is a number system? Number system is basically a system of counting. A system of counting. Basically, number system is just how to count things. How to count things, or I can say how to represent numbers. You have numbers and how to represent those numbers. That is your number system. For example, you know the Roman system. How to represent, for example, if you have these items, if these are your items, then tell me how to represent this in Roman system. How to represent these. So how many items you have? For example, here you have 3 items. So in the Roman system, you will represent like this. Like this you will represent. Here, okay, in the Roman system, you will represent like this. Like this you will represent. And in the Roman system, you will represent like this. Okay, so correct. So are you getting the point? What is a number system? Number system is basically ways of representing numbers. How do you represent numbers? Or I can say how to count things. You want to count things. For example, if you want to count these things, then in Roman system, you will write like this. Okay, in Roman system, you will write 5 like this. So very simple. Here you have 9, total 9 apples you have. So in the Roman system, you will write like this. Correct? So very simple. Now let's see the unary system. This is another system. So many different type of many different type of number system we have. Many different. This is the first Roman system. Okay, this is how we represent the data. This is how we represent the numbers in the Roman system. Now let's see the unary system. Okay, like for example, how small babies will count. You know, how LKG, UKG students, they will count. So what they will do? What they will do? For example, if they want to count, let's assume if they want to count 3, then what they will do? They will count 3 like this. They will count like this. Correct? This is how they will count 3. Correct? Very simple. So this is how small babies will count. This is how. So what they are doing? How many symbols they are using? Can anyone tell me? How many symbols? Only one symbol they are using. So only this symbol they are using. Okay, very simple. So this is the idea. Now, for example, how they will count this? To count this, they will write like this. Okay, this is how they will count it. Very simple. So this is how, okay, how to count this? How to count this? They will count like this. So number system means how to count. So if you have 4 apples, then they will count like this. So remember, what is a number system? If anyone asks you what is a number system? Number system is a system of counting things. How to count things. For example, how to count these things. So in the unary system, we only have one symbol. This is your symbol. Remember, this is your symbol in the unary system. This is your symbol. Only one symbol we have. So number system is a system of counting. How to count things. How to represent numbers. This is the idea. Okay, very simple. Next, the next number system is decimal number system. This is our favorite. Like how normal human will count. Yes or no? How the normal humans, like this is the most favorite. I can say decimal system is what we use every day. Okay, for example, in the decimal system, how many symbols we use? How many symbols we use? 10 symbols we use. 0, 1, 0 to 9. So these are the 10 symbols we use in the decimal system, 0 to 9. And these symbols are called digits. These symbols, remember these 10 symbols, these symbols are called digits. We call them digits. For example, if you have, for example, this, how will you count this? This is one item. So, okay, in the decimal system, you will count like this. In the decimal system, you will count like this. In the decimal system, do we have a symbol for this? Yes, we have a symbol for this. Correct? Yes or no? So very simple. So you can notice that this is how you count in the decimal system. This is now one thing you tell me. If I have these many things, do we have a symbol in the decimal system? Please understand my question. Do we have a symbol? Do we have a symbol in decimal system for this? Do we have a symbol for in the decimal system? We don't have a symbol. There is no symbol. We don't have a symbol because what are the symbols? What are the symbols? So what are the symbols in decimal system? In decimal system, these are the symbols. Okay, these symbols in the decimal system. you know, in the decimal system only these are the symbols we have. In the decimal system we only have these symbols, and these symbols we call them, these symbols in the decimal system we call them digits. Okay, so these symbols are basically digits. Now do we have a symbol for to count these things? There is no symbol, we don't have any symbol. So we are running out of the symbol. You can notice, if I want to count these things, then I have a symbol. If I want to count these things, I have a symbol. If I want to count these things, I have a symbol. So okay, these things, they are denoted by this symbol. Correct, very simple. But now I don't have any symbol, so what should I do? I don't have any symbol to represent these things, so what should I do? I use one more digit. I use two digits. Okay, what I will do, I will use two symbols, because I am running out of the symbols. So what I will do, I will use two symbols. So this is the idea. Okay, so what I will do, I will use two symbols, 1 and then 0. This is the idea. Is this clear to everyone? So what I'm saying, so basically you have symbols, like these are the symbols you have. For example, 0 to I can say 0, 1, 2 and so on. Then these are 9. These are the symbols. Now these are the symbols. Now if I want to count more, if you want to count more, then what you need to do? Now this is what you need to do, that you need to use two symbols. Okay, like this you do. So you put 0 here and you put 1 here. So this is how you do. And then what you will do again, now okay, just fix this one. This we have one, you fix this one, and then you will go till 1 9. Okay, if I want to count more, then what I will do? Now I will change this symbol. If I want to count more, then I will change this symbol. And then from this to 29, I will go. Like this I will go. Then, okay, if I want to count more, then I will change this symbol. And then again, I will go from here to here. So like this I will go. Okay, very simple. Finally, if you get this, okay, like now I am running out of the symbol. Now what should I do? Tell me. See, I have, okay, like this, for this second position, now I am running out of the symbol. Here I am running out of the symbol for first position. Yes or no? Notice, very interesting thing. Here I am running out of the symbol for first position. For one position, I am running out of symbols. Then I am using the second position. Now for the second position also I am running out of the symbols. Then what should I do? Now I should use three. Now what should I do? I should use three symbols. Yes or no? Like this. I hope you are getting this point. So what I'm saying, okay, this is your decimal system. This is how we do. So in the decimal system, these are the symbols. Only 10 symbols we have. And you can notice, when I run out of the symbol here, then what I will do? I will use two symbols. Okay, like this and so on I will go. Now let me tell you what is base of a number system. What is the base of a number system? Base of a number system basically means how many symbols you have in that system. Okay, this is the definition. Base of a number system, that is simply the total number of symbols in that number system. So for the decimal system, what is the base? For the decimal system, what is the base? For the decimal system, base is 10. Okay, so this is the idea. For the decimal system, in the decimal system, we have total 10 symbols. So for the decimal system, base is 10. Okay, this is the idea. Now base, now you can read here. So you can read here. So what is a base value? Base value is the basically is the number of different values the set has before repeating itself. Okay, so you have, these are the symbols. Now they will repeat themselves. Yes or no? Can you notice they will repeat themselves? Now you repeat them. So this is the idea of base. Okay, base means how many different values you have. Okay, have before you repeat yourself. Okay, so that is the idea. Now tell me how to read a number in decimal system. Like how to know, like how many values are these? If I ask you how many values you have here, how many values, like how many items you are counting here. So how to know that? Okay, how many items you are counting here, total how many apples you are counting here. So remember what, okay, remember, so this will be how many items you are counting. How to find that? Very simple. That remember, this is a decimal system. So in this decimal system, every position has a weight. Like, okay, this position has weight 10 power 0. This position has weight 10 power 1. And the next position, for example, if you have a next position, then that next position will have weight 10 power 2. Okay. From where this weight is coming? Like from where this weight is coming? This weight, like, can anyone tell me from where this weight is coming? This weight is coming because remember, when you use this second digit, tell me, when you use this two symbols, like when you use this second symbol, when you use after 10 symbols, yes or no? After 10 symbols, you use this symbol. And when do you use this symbol? When will you use this symbol? You will use this symbol after 100 symbols, after 100 numbers. Is this clear? I hope this point is clear. From where this weight is coming? This weight is coming because this symbol you will use after 100 symbols, or I can say after 100 numbers. This symbol you will use after, this symbol you will use after 100 numbers. This symbol you will use after 10 numbers. So that is the reason from where this weight is coming. So what I can say, how many apples you are counting here? This number, how many apples this number will count? Very simple. So this number will count like this. So 9 into 10 power 0. How many hundreds you have? How many hundreds you have? 2 hundreds you have. How many hundreds you have? 2 hundreds you have. How many how many tens you have? How many tens you have? 2 tens you have. And how many hundreds you have? 3 hundreds you have. So this is the idea. Okay, focus on this. Focus on this, from where this base is coming. Like from this weight are coming. From where these weights are coming. These weights. Okay, why these weights are coming? Because, for example, this weight, why this weight is coming? If anyone asks you, from where this weight is coming? This weight is coming because I am using this second symbol. I am using this second symbol. This is second symbol. Okay, this is second symbol I am using. This is second symbol I am using after. So second symbol 2, okay, after 10 numbers, after 10 items, I can say, after counting 10 items, after counting 10 items, 10 items. Okay, and similarly, the same thing I can say for this, the third symbol, same thing I can say for the third symbol. So what I will say for the third symbol, this third symbol, and the third symbol is 3. This third symbol is basically 3. So, okay, this symbol I am using after counting 100 items. Very simple. Okay, so this is the reason. If anyone asks you from where these weights are coming, these weights are coming because of this situation. So after counting how many items, you are using that symbol. Okay, so this symbol we are using after counting 100 items. So that is the reason this weight is coming. That is the reason this weight is coming. Okay, is this point clear? So very simple point. So this is the idea. So for example, if you have this number in the decimal system, then from where this, tell me, from where this weight is coming? What is the meaning of this weight? This weight is coming because this symbol we are using after counting, I can say, after counting 10,000 numbers, after counting 10,000 items, after counting 10,000 items. These symbols we are using after counting 1,000 items. This symbol we are using after counting 100 items. This symbol we are using after counting 10 items. Okay, so this is the idea. This is the idea of weight. So finally, this so if you have this number 22706 in the decimal system, I can say how many ones you have. So I can say these many ones you have, plus how many tens you have, how many tens you have, 0 tens you have, how many hundreds you have, how many hundreds you have, these many hundreds you have, how many thousands you have, 2,000s you have, and how many 10,000s you have. Okay, there are 2 10,000s. So like this you will write. Is this clear to everyone? The decimal system, is this clear? In the decimal system, for example, if I give you this value if I give 1000, then what it will become? This is in the decimal system. Remember, this number is in the decimal system. This number is in the decimal system. It's this tells us number system. This tells us the number system. So decimal number system we are using. So I am using 10 here. So this number is in the decimal system. It means what? It means that how many tens you have? Sorry, how many ones you have? Like 10 power 0. How many ones you have? 0 ones you have. How many tens you have? 0 tens you have. How many hundreds you have? How many hundreds? 0 hundreds you have. And how many thousands you have? 1,000 you have. So if you add all of them, you will get 1000. Okay, if you add all of them, so just add all of them. Similarly, if you add all of them, then you will get 22706. This is what you will. So this is your number, the decimal system. Is this clear? Is this clear? In the decimal system, if you have any number, like if I give you any number, for example, A, B, C, D, E, if I give you this number in the decimal system, okay, this 10 basically means the decimal system. It simply means that your system is decimal system. Because your system is decimal system, so I can say that this number will be, I can say E multiplied by 10 power 0 plus D multiplied by 10 power 1 plus C multiplied by 10 power 2 plus B multiplied by 10 power 3 and plus A multiplied by 10 power 4. Okay, so A will be multiplied by 4. Is this clear? This A is multiplied by 10 power 4. This B is multiplied by 10 power 3. This C is multiplied by 10 power 2. Because this C we are using after consuming 100 items, after counting 100 items. Is this clear? This C we are using after counting 100 items. Okay, so it means how many 100 items we have? Okay, tell me. This C we are using after counting 100 items. So how many 100 items you have? Like here, if I give you this number 256, what this means? This means that what this means? This means, tell me, after counting how many items we are using this symbol? We are using this symbol after counting 10 items. Okay. Now tell me how many tens we have counted. Okay, so this is the idea of this we are using after counting. This symbol we are using after counting 10 items. Okay, after counting 10 items, this is second symbol we are using. Okay, so I can say this is second symbol. This is second symbol we are using. We are using after counting 10 items. And tell me from this 5 tells you what? This 5 tells us how many tens you have counted. How many tens you have counted? Tell me how many tens we have counted. How many tens we have counted? Okay, so total 5 tens we have counted. Is this clear? These two things, did you understand? Did you understand these two things? How many tens you have counted? This 5 tells us how many tens we have counted. So we have counted 5 tens we have counted. Yes or no? Like in this number, like when you have this number like 22, it means 2 tens we have counted from 0 to 9 and from 10 to 19. So 2 tens we have counted. Then this 2 is coming. Then this 2 is coming. So this 2 will come after counting 2 tens. Okay, 2 tens we have counted. Is this clear? After counting 2 tens, after counting 2 tens, we are using this second symbol we are using. So this is the idea of decimal system. So if I give you any number in the decimal system, any number, for example, whatever number I give you, like 1253, if I give you this number or 1255, then what this number means? So this number simply means what this means. This means how many? Tell me how many hundreds we have counted. How many hundreds we have counted? How many hundreds we have counted? How many hundreds we have counted? So the answer is 2. 2 hundreds we have counted. And what this means? This means how many thousands we have counted. This means how many thousands we have counted. We have counted. Okay. So total 1000 we have counted. Okay. So this is the complete idea of decimal system. So this is the idea of this weight. If someone asks you from where these weights are coming, then this is how the weights will come. Okay. So this has weight 10 power 0. This has weight 10 power 1. This has weight 10 power 2. This has weight 10 power 3. Okay. So finally, this number is nothing but 5 into 10 power 0 plus how many tens you have? 5 tens you have. How many hundreds you have? 2 hundreds you have. And how many thousands you have? 1000 you have. So this is the idea. Anyone has any doubt? Let me know, because now we will go to the binary system. Please let me know if anyone has any doubt. Let me know, please tell me. This is the idea. This is the idea of decimal system. Everyone got it? Everyone understood? Okay. So yeah, let's move on. Now let's see this number system. This next number system, that is binary number system. This is the computer number system. This is the number system that we use in computers. Okay. So how a computer will count? So how many symbols we have? I told you in the last class, we have two symbols, 0, 1. These symbols we call them, these two symbols we call them bits. These are called bits. These symbols, these are called bits. Okay. So this is also very similar. Remember, this binary number system is also very similar to decimal number system. We have only two symbols. We have only two symbols. So tell me, if I want to count, if I want to start my counting, then I can count 0. Then I can count 1. Okay, see here, decimal, here I'm writing decimal, and here I'm writing binary. These are actually very similar. Okay, notice very similar. If I want to count 0 things, I can count like this. If I want to count one apple, if I want to count one apple, I can use this. Now tell me, did I run out of symbol? Am I running out of the symbols? Did I run out of the symbols? Now I don't have any symbol. Do I have any symbol for this? Is there any symbol for this? There is no symbol. There is no symbol here. Here there is no symbol for 2. We don't have any symbol for 2. So how to count this 2? If I want to count 2 apples, then how to count? 2 symbols you use. 2 symbols you use. Same as decimal. If I want to count 2 apples I want to count, then use 2 symbols. Okay, so like this you count. Okay, so very simple, 1 and then 0. If I want to count 3, then I can do this. Next, did I run out of symbols? Again, am I running out of the symbols? Am I running out of the symbols? Yes. Again, I am running out of the symbols. So, okay, if I want to count, for example, if I want to count 4 apples, I want to count 4 apples. Now I don't have, okay, I will have to use one more symbol. I will have to use one more symbol because now I am running out of the symbols. I cannot do anything. So now I will, okay, like this I will do 1, 0, 0. Then if I want to count this 5, then what I will do? Very simple, 1, 0, 1. Okay, 6 if I want to count. Now remember, now I am again running out of the symbol for the first position. For the first position, I am running out of the symbol. So in the second position, I can use 1. In the second position, I can use 1. Okay, now, okay, like this I can count. So and so on. If I want to count 8, now I am running out of symbols. So I will use 4 symbols. I will use 4 symbols. Is this clear? You can notice here I am running out of the symbols. Here also we are running out of the symbols. Is it clear to everyone? So this is the idea. So notice that these two things are actually same. The decimal system, in the decimal system, what we do? In the decimal system, when you have greater than 9, then you use new digit. When you have greater than 9, then you will use new digit. Okay. Similarly, in binary system, when you have greater than 1, you will use new digit. So this is the simple idea. In the binary number, amount of things. So how many things we have here? Like, okay, how many apples you have here? How many apples? You can notice 0 apple. How many apples? 1 apple. How to count this? 1, 0. Because we are running out of the symbol. So, okay, this 0 apple, 1 apple. Then, now if I want to count 2 apple, then I have to use this 3 apple. I have to use this. Okay, and the remaining we have seen. If you want to count 4 apples, 5 apples, 6 apples, and so on. So it will keep going. So, for example, if you have 7 apples, you will count like this. 8 apples, you will count like this. Is this clear? Is this clear to everyone? Now, so in the decimal, in the similar to decimal system, in binary system, what happens? Similar to the decimal system. Tell me one thing in the binary system. Okay, this is what you tell me. In the binary system, let's find out the weights. In binary system, find out the weights. Find out the weights. Okay, so let's find out the weights. For example, if I give you a binary number, let me give you a binary number like this, 1011. Okay, this number. Tell me what this means. Can anyone tell me? Like what this means? Remember, this is second symbol. Why we are using this second symbol? This is second symbol. Why we are using? This is second symbol we are using after counting how many things? Used after counting After counting how many things? After counting two items, correct? After counting two items, we are using this second symbol. Very simple. Okay, just similar to decimal system. And what this means? So this fourth symbol I am using, this fourth symbol used after counting how many items? After counting how many items? After counting 8 items. Total 8 items you are counting. After counting 8 items, you will use this. Okay, I hope this point is clear. So what is the weight of this? Like, let's find out the weights. See, okay, see this. So what is the weight of this first symbol? The first symbol, whatever symbol you have, for example, let's call it A0. So what is the weight of this symbol? That is 2 power 0, or I can say 1. That is simply 1, or I can say 2 power 0. What is the weight of this symbol? What is the weight of this symbol? So after counting two items, you are using this. What is the weight of this symbol? After counting 4 items. After counting 4 items. So are you getting my point? If anyone asks you, then this is how you can explain. See, what I'm telling you, you already know all these things. I'm just telling you from where these weights are coming. Many students, they just by heart. Okay, this is by heart. Okay, yeah, this is binary. See, this type of thing. Like, can you tell me, did you by heart? Like, did you by heart that, okay, this is the weight 2 power 0, this is the weight 2 power 1, this is the weight 2 power 2, 2 power 3. Okay, then what they will do? They will just by heart. I'm just trying to explain from where these weights are coming. This is what I'm trying to explain. If you understood, then very good. If you did not understand, then just by heart, no problem. Okay, because in the GATE exam, they will not ask you from where these weights are coming. But I just want to explain that, okay, from how these things are happening. This is what I want to explain. Did you understand? Did you understand from where these weights are coming? So you don't have to by heart. Okay, so don't by heart, just understand. So this is the simple idea. So in the binary system, what are the weights? So remember, this has the weight 2 power 0, this has the weight 2 power 1, this has the weight 2 power 5. Okay, this has the weight 2 power 5 because there are 5 symbols on the right of it. This has weight 2 power 4 because there are 4 symbols on the right of it. This has the weight 2 power 3 because there are 3 symbols on right of it. This has the weight 2 power 2 because there are 2 symbols on right of it. So this is the idea. Now tell me how many items we have counted here. If I give you a binary number, like this is a binary number. What this tells us? What this will tell us? This tells us binary system. This tells us that number is in the binary system. This number that you have given, that number is in the binary system. So how many apples we are counting with this number in the binary system? How many apples we are counting? Very simple. This has the weight 2 power 0. This has the weight 2 power 0. This has the weight 2 power 1. This has the weight 2 power 2. This has the weight 2 power 2. And this has the weight 2 power 3. Okay, so because this is 0, so it will basically 0, it will become 0. And then finally, what you will get, if you add all of them, then you will get 8 plus 2 plus 1, and that is your 11. So 11 apples we are counting. Is this clear? How many apples we are counting? Total 11 apples we are counting. This is 11 in decimal. This is not the 11 of binary. This is the 11 of decimal. 11 apples you are counting. Remember what is 1 in binary? What is 1 in binary? This has the weight 2 power 0. This has the weight 2 power 1. So finally it will be 3. Okay, so if you have this in the binary, then you are counting 3 apples. And if you have this in the binary, then you are counting 11 apples. I hope this point is clear. Okay, so very simple. This is the very simple point. These two number systems we have seen. Now let's take many examples. If you did not understand something, then let me clear everything by this example. So let's see the base 10 means decimal number system. In the decimal number system, remember, if you have a number, whatever number you have, if you have a number 22003, if you have a number, then in this number, every position has a weight. Every position has a weight. This has weight 10 power 0 because this is a number in decimal system. This is the number in decimal system. So this has weight 10 power 0. And what is the weight of this? There are 4 things in the right. There are 4 symbols on the right. So this will have 10 power 4 weight. Okay, this is the weight 10 power 3. This has the weight 10 power 2, and this has the weight 10 power 1. Okay, now finally if you calculate, then what you can say, you can say that these are 0, so you don't have to worry. So you can multiply this 3 with its weight, you can multiply this 2 with its weight, and you can multiply this 2 with its weight. So this is how you can do. Very simple. Okay, so in the decimal system, remember, in the decimal numbers, each digit is multiplied by a appropriate power of 10 depending on the position. So each digit has a weight, each digit will have a weight. So this will have weight 10, this will have weight 10 power 3, because there are 3 people on the right, so this will have 10 power 3 weight. And the same thing you can do for binary system. In the binary system, each binary digit is multiplied by appropriate power of 2. For example, if I give you this binary like 101, then this is in the binary, then what will be in the decimal? In the decimal, like how many apples you are counting, So very simple, remember, every bit has a weight. Okay, so because it is in binary, so every bit will have weight in the power of 2, Okay, so finally what it will become? It will become 1 into 2 power 2 plus 0 into okay, 2 power, so this is 0, so you don't have to worry, because this will become 0 when you multiply by 0, and this will become like this. So finally what you will get? You will get 5. Okay, if you add this, then you will get 4 plus, okay, so 5. So total 5 apples you are counting. Very simple. So this is the complete idea. So now let's see. Binary to decimal is very easy, right? Yes or no? Binary to decimal is very easy. Same as you read decimal number. So this is very easy. Binary to decimal. If I give you any binary number, how to, or like whatever binary number I give you, like if I give you this binary number, then what will be the corresponding number? If I give you this binary number, then what will be, how many apples you are counting? With this binary number, how many apples you are counting? Like what will be the number in decimal? So very simple, just multiply everything with its weight. So what is the weight of this? Tell me, what is the weight of this? There are total 6 symbols on the right. So this will have weight 2 power 6. This will have weight 2 power 6. And next, this will have weight 2 power 4. Next, this will have weight 2 power 3. And next, this will have weight 2 power 1. And next will have weight 2 power 0. So what you will get here? 2 power 6, that means 64. 2 power 4, that means 16. 2 power 3 is 8. 2 power 1 is 2, and plus 1. So if you add all of them, you will get your answer. You will get the answer. Okay, so the answer will be 91. So total 91 apples you are counting. When you write like this, then you are counting total 91 apples. Similarly, if you have this number in the binary, then how to convert in decimal? Very simple. Just multiply everything with its weight. What is the weight of this? There are total 7 people. On the right. So this you will multiply with 2 power 7. Okay, this you will multiply with 2 power 7. This you will multiply with 2 power 6, and so on. So finally, this will be the value in decimal system. So this is very simple. So from binary to decimal is very simple. There is no problem. Okay, very simple. Now let's see from decimal to binary. Now here is my question. Some of you already know how to convert from decimal to binary. Some of you already know. Okay, what you do to convert from decimal to binary? What you do? Can anyone tell me what do you do? You divide. Yes or no? You divide by 2, something like that. Okay. Now, do you know why? Do you understand why? What is the reason? Do you understand? Like, okay, so let me tell you what people do. Let me tell you. See, don't worry. If you don't know, I will explain. But let me just tell you what many students they do. For example, if you have a number, like if you have a number 14, this is in the decimal, then what will be the binary? In the binary, what it will become in the binary? So what people do? People do like this. See, people do like this. Okay, because they want to convert to binary from decimal, they want to convert to binary. So what they will do? They will divide by 2. Okay, when they divide by 2, they will write remainder here. So when they divide by 2, then the remainder will be 0. When you divide 14 by 2, remainder will be 0. And here you will write the quotient. So this will be the remainder 0. Then again you divide by 2. Then the remainder will be 1 and quotient will be 3. 3 times you will divide, yes or no? 3 times you will divide. Okay. So again you will divide by 2. Then one time you will divide and 1 will be the remainder. Again you divide, 0 times you will divide, 0 times you will divide, and the remainder will be 1. And what people will do? What people will do? Then they will write like this. Like this, okay, from bottom to down, from bottom to up, sorry, from bottom to up, you write like this. So finally, I can say that this is your decimal, and in the binary, your answer will be 110. This will be your answer in binary. So 14 in the binary, 14 in 10, that is in the binary, that is basically 110. This is in the binary. So this means total 14. What this means? How many items? This means how many items? Total 14 apples. This simply means total 14 apples. Okay, very simple. Now let me tell you, okay, so this is the idea. This is the complete idea. So this is how you do. From decimal to binary, if you want to convert, then this is what you do. I will explain why. Don't worry, I will explain. But let's do the practice. I will explain this, why we do this division. But basically, if you want to convert any number from decimal to binary, if you want to convert any number from decimal to binary, if you want to convert, then what you do? Then the method is successive division by 2. This is the method. This is the method, successive division by 2. Division by 2. Okay. And then what you do? The remainders that you get. Okay. Write remainders in what order? Write remainders in reverse order. In reverse order. Okay. So very simple. So write the remainders in reverse order. This is the method. Now let's do the practice of this method. So let's do, for example, if I give you this number 27, then 27, this I am giving you. So what will be in the binary? In the binary, what it will be? So you have 27. What you will do? You will divide by 2. The remainder, here you will write the remainder. This remainder you will write here. So when you divide 27 by 2, okay, how many times you will divide? 13 times you will divide. How many times you will divide? 13 times you will divide. The remainder will be 1. Okay, then again you divide this 13. So the remainder will be 1. 6 times you will divide. Then again you divide, remainder will be 0. 3 times you will divide. Then again you divide by 2. Then remainder will be 1. 1 time you will divide. 1 time you will divide. Now 0 time you will divide. You will divide 0 time and you will write like this. Then these remainders you write in the reverse order. These remainders you write in the reverse order. So the answer will be 11011. 11011. This will be in the binary. So this is the binary of, I can say this is the binary of 27. This is the binary of 27. Is this clear? This method is actually, this method will take a lot of time. If you have big numbers, then this method will take a lot of time. But this method is very simple. Okay, let's do the practice of this method. So can you try to 32? Can you try 32? In the binary, what it will become? This 32, okay, what it will become in binary? In the binary system, what it will become? So the idea is very simple. You will divide this 32 by 2, successive division, and you will write remainders. These remainders you will write here. So how many times you will divide? 16 times you will divide. Okay, so this 32 you can divide 16 times, then the remainder will be 0. You can divide this 16 8 times, the remainder will be 0. Then you can divide this 8 4 times, the remainder will be 0. Then you can divide 2 times, the remainder will be 0. Then you can divide 1 time and the remainder will be 0. And then finally you can divide 0 times, the remainder will be 1. So you write in this direction. So finally what you will get 1 and then 5 zeros. Then 5 zeros. Okay. So this will be your binary. This is the binary of 32. This is the binary of 32. Is this clear? Now let me explain from where this method is coming. Like why do we do this method? This method, why we write in reverse order, why we divide by 2, okay, why this successive division? So let's understand this. And the idea is actually very simple, very simple. Tell me one thing. Okay, if you have any binary, like if I have this binary A, B, C, D in binary, this is in binary. So tell me what is A? If this is binary, then what is A? What is A? Either 0 or 1. A is 0 or 1, C is 0 or 1, D is 0 or 1. Yes or no? Agree? because this is a number in binary system, in the binary system. So let us assume this is the n in decimal system. Let us assume. Then tell me, if this number is n in decimal system, this number of binary is in the decimal system, this is n, then what is this n? N is equal to what? I can say n is equal to okay, a into 2 power 3 plus b into 2 power 2 plus c into 2 power 1 and plus d. Is this clear? Is it clear to everyone? Is this clear to everyone? And remember, what is a comma b? What is a comma b comma c comma d? They belong to 0 comma 1 because they are in the binary. This is the binary system, so it simply means that a comma b comma c comma d, they are the binary, they are the bits. Okay, so this n will be like this. Now tell me how to find d. This is my question. How to find d? If I want to find this d, how to find d? How to find this d? This first position. How to find this d? What should I do? This d, can I say this d is equal to remainder? Can I say this is remainder when you divide n? Can I say this is n mod 2? Can I say this is n mod 2? Yes or no? When you divide this number by 2, just divide this number by 2. Remember, this d is 0 or 1. This d is 0 or 1. This is d. So when you divide this number by 2, then the remainder will be d. Yes or no? Is this clear to everyone? This number, for example, this is your number n. So when you divide by 2, then this is the remainder, because this number, this will divide by 2. You can divide by 2, you can divide by 2, you can divide by 2. The remainder will be this. This d will be the remainder. So I can say, what is d? D is the, I can say d is the, I can say that is n mod 2. Is this clear? So how to find d? Now tell me how to find c. So remember, how to find c? This is what I want to ask. You have a, b, c, d in number system, and this is the decimal. Then you already know that n is equal to a into 2 power 3 plus b into 2 power 2 plus c into 2 power 1 and plus d. So how to find d? Sorry, how to find c? How to find c? If you want to find c, then what you will do? See, this is what you will do. First, you will divide this by 2, then the quotient you will get. You will get a quotient. That quotient you, okay, so basically, yes or no, when first you will divide by 2. Now this d is gone. If you divide by 2, then what is the quotient? So let's assume this q. What is the q? Let's assume this q is the quotient. Let's assume this is the quotient when you divide n by 2. When you divide n by 2, let's assume this is the quotient. So how to find c? C is basically this first, I can say this q1. I can say the first quotient. I can say c is equal to first quotient mod 2. Yes or no? Yes or no? Because when you divide this n by 2, this number n, when you divide by 2, then what will happen? What will be the quotient? Can anyone tell me? Can anyone tell me what will be the quotient? This is your number. Your number is a into 2 power 3, b into 2 power 2, c into 2 power 1 and plus d. So tell me, what is the quotient? When you divide by 2, then what will be the quotient? What will be the quotient? And what will be the remainder? What will be the remainder? So what will be the quotient and what will be the remainder? So the remainder will be d and the quotient will be a into 2 power, the quotient will be a into 2 power 2 plus b into 2 power 1 plus c. This will be the quotient. Is this clear? Tell me, is this clear? A into 2 power 2, b into 2 power 1 and plus c. This will be the quotient. Because when you divide by 2, just find out, if you divide by 2, this will cancel. Okay, like, okay, you will get 2 power 2, you will get 2 power 1, you will get, okay, so this will cancel. So this d will be the remainder and this will be the quotient. Let's call it quotient q. This is the first quotient. So let's call it q1. This is the first quotient. Okay, and this is your first remainder. So let's call it, this is the first remainder. So let's call it r0. Let's call it r0, that will be g. Okay, and this is your first quotient, q1. So like, or maybe r1, you don't have to worry. So you can just write r1. So then what you will do? Then what is c? What will be c? Can anyone tell me what will be c? How to find C from this? How to find C from this? Tell me. How to find C from this quotient? From this quotient, how to find C? That will be the remainder when you divide this by 2. So this C will be Q1 mod 2 and so on. So this is what will happen. Okay, this is what is happening. So tell me, like this is the successive division. When you do the successive division, successively you are dividing the quotient. Successively you are dividing the quotient. So like this is happening. So again, now this is your Q1. What is your Q1? That is A into 2 power 2 plus B into 2 power 1 and plus C. This is your Q1. So tell me, what is Q1 divided by 2? What is the quotient? What is the quotient Q2 and what is the remainder? What is the remainder? The remainder R2. So the remainder R2 is C and the quotient, when you divide this by 2, you are dividing this by 2. So the quotient will be A into 2 plus B. Now you can notice how to find B. Tell me how to find B. So this is your, so find B. What that will be? So this is your Q2. So you know that Q2 is basically A into 2 plus B. So find B. How to find B? Find B. That will be basically, B is nothing but when you divide this Q2 by 2, then you will get the remainder. So this remainder, okay, this remainder will be the P and so on. So this is the idea behind this proof, behind this algorithm. Okay, so this successive division, why do we do successive division? The process we complete, this process we do, okay, as long as, and tell me, so this is the process, this process we will continue. This is the idea. So for example, if let's take example, with example, this concept will be clear. So let us take this example, like, okay, 27. Let us assume this 27 you have. Okay, like what will be the number? 27. So tell me, what you do here, this is your 27. Then I told you how to find the, okay, let's assume this is your binary. Let us assume your binary is A0, A1, something, A0, A1, A2, something. So tell me how to find this A0. Tell me how to find this A0. Remember, this is your N. This is your N. So how to find this A0? So how to find this A0? I told you that this A0 will be, when you divide this, then the remainder will be the A0. So this will be your A0. Okay. And the quotient, will be 13. Quotient will be 13. This will be your first quotient. And this will be your first remainder. Okay. So what is the second remainder? What is the second remainder? The second remainder will be 1. The second remainder will be 1. And that will be your A1. That will be your A1. Then, okay, what is the quotient? The quotient will be 6. So this is your Q2. Okay, this is your Q2. Then what will be the third remainder? The third remainder will be 0. This will be your A2. This will be your A2. What is the quotient? The quotient is 3. This will be your quotient Q3. Then what is the remainder? The remainder is basically 1. This will be your A3. Okay, and the quotient will be 1. The quotient will be 1. The quotient will be 1. So what is the next remainder? The next remainder is 1. This will be your A4. Okay, and the quotient will be 0. And the quotient will be 0. Okay, so can you notice why we write in the reverse order? Can anyone tell me why we write in the reverse order? Like these, we write them in the reverse order. Why? Now you can notice why we write in the reverse order. Because the first remainder that you get, that is your A0. Your first remainder is actually A0. First remainder is A0. And the second remainder is A1. Third remainder is A2. Fourth remainder is A3. And the next remainder is A4. So that is the reason. That is the reason we write this in the reverse order. That is the reason we write this in the reverse order. Because this first remainder is your A0. And this is your A4. This is the reason we write in the reverse order. Did you understand? Please let me know. Like, did you understand why we do this? So idea is very simple. Let's take just one another example. Let me take one more example. So let's assume you have 44. Let us assume you have this 44. Then what to do? The same thing. This is the value n. You know, this is your n. Okay. Now this is the value n. So what you will do? You will divide. So this is what you will do. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So this is what you will do. You will divide. So and the remainder, you will get a remainder. This is your n. So when you divide the quotient, the first quotient, what that will be? The first quotient will be 22. This will be your first quotient, and the first remainder will be 0. This first remainder is your a0. This first remainder is your a0, because remember, if you have n equal to 44 in the decimal, then what will be in the binary? What will be in the binary? A0, A1, A2, A3, A4. Okay, so this is your binary. So you can notice this A0 will be your R1. The first remainder will be A0. Very simple. Then you got a quotient. You got this quotient. Now this quotient you divide, then what will be the next remainder? This quotient you divide, then what will be the next remainder? The next remainder will be 0. This will be your A1. Then next quotient will be 11. Next quotient will be 11. This next quotient you divide by 2, then the remainder will be 1, and this will be your A2. And the next quotient is 5. The quotient is 5. Then again you divide by 2, then what will be your remainder? Your next remainder will be 1. This will be your A3. What will be the next quotient? The next quotient will be 2. Then you again divide by 2. The next quotient will be Q5. And the remainder will be, actually, when you divide this, then the remainder will be 0. This will be your A4. And then finally, the last quotient will be 0, and the remainder will be 1. This will be your A5. Okay, so this is going to be your A5. Okay, so this is going to, so that is the reason we write in the reverse order. So finally, what will be the answer? You can notice the first remainder is actually A0. Remember, the first remainder is A0. So this is your A0. This is your A0. This is your A1. This is your A2. This is your A3. This is your A4. This is your A5. I hope this point is clear. So how to convert this 53 into binary? Very simple. This is your n. This is your number n. So you will divide. This will be your quotient. This will be your first quotient. This will be your second quotient. And you are getting the remainders. You can notice the remainder that you get, that will be your A0. The next remainder will be A1. The next remainder will be A2. So if you write this number in binary, this number, let's assume this number is A5, A4, A3, A2, A1, A0. So now you can notice that your first remainder is A0. Your second remainder is A1. Your next remainder is 1. Your next remainder is A3. And your next remainder is A4. Next remainder is A5. So this is how you will write. I hope this point is clear. Similarly, this is another. You can notice, very simple. You can notice this is your number n. This is the number n. So these are the quotient and these will be the remainder. So these, in this remainder list, if you notice, this is your A0 actually. Okay, so this is A0, this is A1. So that is the reason we write in the reverse order, because we are getting the numbers in the reverse order. Okay, these bits we are getting in the reverse order. We are getting the first remainder that we are getting, that is this. So this is your A0. Is this clear? Please let me know. So far, whatever we have seen, did you understand? What we have seen in today's class, did you understand? The number system, did you understand? Number system. So the number system is very simple topic, this number system. Okay, you have, so in the number system, this is the final conclusion. You have these items. So let's assume how many items you have. For example, let's assume you have these items. So these are your, let's assume these are your apples. Let's assume these are your apples. So how to count them? Then the decimal system will say that, okay, this is the value. The decimal system will say this is the value. The binary system will say this is the value. The Roman system will say this is the value. Okay, so the Roman system will count like this, the decimal system will count like this, and the binary system will count like this. Is this clear to everyone? Very simple. So this is your number system. Number system means how to count things. This is the definition of number system. How to count things. Now remember one thing. Remember, yes, and the unary system, if you notice, the unary system will count like this. This is how unary system will count. Okay, very simple. This is how unary system will count. This is how English will count. This is how English will count. Okay, this is how English will count, right? Something like this. Okay, anyway. Priya is asking, one doubt I have, why while converting binary to decimal, we are considering base 2, not base 10. I told you the reason, Priya. See, from binary to decimal, when you convert, okay, like if I give you a binary number, this reason I told you, when you have a binary number, for example, let's assume this is your binary number. Now in this binary number, tell me why, okay, what is the weight of this symbol? This is the binary number. What is the weight of this symbol? The weight of this symbol is 2 power 1. Why? Why? Okay, this is the weight. But the question is why? Can anyone tell me why this is the weight? Can anyone tell me why this is the weight? This is the weight because the second symbol we use after counting 2 items. We use second symbol. We use, okay, this is the reason. I told you the reason. If anyone asks you, this is the weight. If anyone asks you why this is the weight, then what you will say? You will say that we use second symbol. We use this second symbol. This is second symbol. This is second symbol we use after counting 2 items. After counting 2 items. Okay, so that is the reason you have this weight. That is the reason you have this weight. And why we have this weight 2 power 3? Because this symbol we use after counting total 8 items. This symbol we use, okay, so this is your, I can say this second symbol, third symbol, fourth symbol. So this fourth symbol we use after counting how many? Fourth symbol we use after counting after counting 8 items. Anyway, this is the reason. If you did not understand, please ignore. Please ignore if you did not understand. Please ignore. This is the summary that you need to remember. Please ignore if you did not understand. Like the logic, if you did not understand, don't worry about it. This is the complete summary. You have any binary number, if I give you, whatever binary number you have, A, B, C, D, E, if you have this binary number, then how to convert to decimal? How to convert to decimal? Very simple, because this is a binary number. So everything has a weight. Everything has a weight in 2 to the power. In the power of 2. Everything has a weight in the power of 2. Only this you have to remember. Only this you have to remember. If you did not understand the logic, then only you have to remember this. So how to convert this binary number into decimal? Very simple. Okay, every digit, every bit you multiply with its weight. For example, this B you multiply with 2 power 3. This C you multiply with 2 power 2. This D you multiply with 2 power 1. And this E you multiply with 2 power 0. This is the idea. Very simple. Okay, so this is how you convert binary to decimal. This is what you have to remember, nothing else. Now remember one thing, this decimal and binary conversion, when you do, don't apply the previous methods because they will take a lot of time. Do quickly. How to do quickly? Let's see. We will not use the previous methods. In the exam, don't use the previous methods. Do very quickly. Okay, and what is the idea of quickly? How to do quickly? So first of all, you remember few things. You remember from 1 to 15 you should remember. Okay, so this is the first idea. You should remember binary of 0 to 15. This is what you should remember. Directly you should remember binary of 0 to 15. So what will be the binary of 0 to 15? So on one side I am writing the decimal and on another side I am writing the binary, and you tell me what will happen. So what is that? If decimal is 0, then the binary will be 0. If the decimal is 1, okay, what is the binary of 1? That is 1. What is the binary of 2? 1, 0. The binary of 3? 1, 1. Binary of 4? 1, 0, 0. Binary of 5? 1, 0, 1. Okay, next, decimal and binary. So tell me, what is the binary of 6? That will be 1, 1, 1, 0. Binary of 7? 1, 1, 1. Binary of 8? 1, 0, 0. Binary of 9? 1, 0, 0, 1. Binary of 10? 1, 0, 1, 0. 1, 0, 1, 0. And then you can notice that what is the binary of, okay, so finally 10, 11, binary will be 1011, 12, 1100, 13, 1101, 14, 1110, and 15 will be 1111. Okay, so these things you should remember. So, okay, actually you can calculate these things. If you forget about it, then you can calculate. Like if you forget what is the binary of 13, then you can calculate. Now let me tell you how to calculate. How to calculate quickly. How to calculate quickly. This is what also what we will see. See, remember these things you should remember. Powers of 2. Powers of 2. Binary of powers of 2. For example, if you have 2 power 0, if you have 2 power 0, 2 power 0 means 1. So what is the binary? These powers of 2 you should remember. And these are actually very easy. Decimal, binary, powers of 2. So for example, 2 power 0, that means 1. And that will be simply 1. That will be simply 1. If you have 2 power 1, that is 2. So that will be 1, 0. 2 power 2, that will be 4. And that is 1, 0, 0. Next, 2 power 3, that will be 8. And that will be 1, 0, 0, 0. Are you getting what is happening? Are you getting what is happening? So what is happening here? 2 power 4, what that will be? 2 power 4 in binary, like this is in the decimal. So in the binary, what it will become? It will become 1 and 4, 0. 1 and 4, 0. So if you have 2 power n, if you have 2 power n, then what will be in the binary? 1 followed by how many zeros? Followed by n zeros. Followed by n zeros. Very simple. This is very simple. How to find? For example, if you want to find what is 2 power 10, what is 2 power 10? 2 power 10 means 1024. This is your 2 power 10. So 2 power 10, 1024. That means 1 and followed by 10 zeros. 50, 50. This will be your binary for 1024. Very simple. Okay. The third thing, how to, okay, tell me. Now, if you have any number, like, okay, for example, now notice what is happening. If I want to find 17, if I want to find what is the binary of 17, if I want to find, notice what I will do. Notice very simple thing I will do. I will do very simple thing. Okay, what is the closest power of 2? Like what is the closest power of 2? You know 16. You already know that. How? Just write 16. Just write closest power of 2. See, what is the closest power of 2? That is 2 power 4 plus 1. That is 2 power 4 plus 1. So the closest power of 2. So you write this 2 power 4. This will be this 2 power 4. This will be 1 and 0, 0, 0. Okay, just write like this. Okay, don't write. Okay, just write like this. Yes or no? Because 17. What is the closest? The closest is 16. The lower. This is the closest 16. So 16 means 1 followed by 4 zeros. So 16. Okay. Now remember, this will give you 16. How much is remaining? This will give you, this one will give you 16. How much is remaining? 1 is remaining. 1 is remaining. This is your 1. This is your 1. So finally, what we got? We got 17. Finally, we got 17. Is this clear what is happening here? Notice. So for example, if I want to find 22, then what I will do? First you write like this. Then what this will give you? What this will give you? This will give you 16 because there are 4. Okay, this will give you 16 because there are 4 on the right. On the right you have 4. So this has weight 2 power 4. This is the weight. Weight is 2 power 4. Correct? So this one will give you 16. How much is remaining? Tell me how much is remaining? Remaining is 6. And this is your 6. 1, 1, 0. This is your 6. Remaining is 6. So this is your 6. So the answer will be like this. Is this clear? So whatever number you have, for example, if I have this number, like let's assume you have this number 6, let's assume 80. You have this number 80. Then how to count? What is the closest? Tell me what is the closest? Closest, how many symbols I should leave? Tell me how many symbols I should leave? Total 6 symbols I should leave. Total 6 symbols. See, there are 6. I will leave total 6 6 space I will leave. This will give me how much? This will give me 2 power 6. This will give me 64. So this is giving me 64. I got 64. How much is remaining? I have 64. How much is remaining? How much is remaining? 16 is remaining. 16. And you already know 16. Array 16 is remaining. 16 is remaining. And you already know 16. 16 means 1 followed by 4 0. 16 means 1 followed by 4 0. Okay, so very simple. This will be your 16. This will be your 16. Is this clear? See, this is a very fast method. Okay, whatever you want to count, you can count. For example, if I want to count 11 of decimal, then what I will do? I will write 1 because this will give me what? This will give me 8. This will give me 2 power 3. This is the weight. This is the weight. This will give me 8. How? Okay, now how much I want? How much I want? I want 3. How much extra? How much extra? 3 I want. 3 is this. This is 3. This is 3. 0 1 1. This is 3. So this 0 1 1 is your 3. That's it. Okay, isn't it very fast? This method is actually very fast. If I give you any number, you can calculate. If I give you, for example, let's assume I give you 165. 165. What that will be? 165. What is the closest? How much space I should leave? Total 7. Total 7 I should leave. So 7 space. Why? Because now this will give me 2 power 7 and that is 128. So this will give me 128. I have 128. How much is remaining? I have 128. How much is remaining? I already have 128. So how much is remaining? How much is remaining? I have 128. So 37 is remaining. I want 37. So remember, for 37, see, if I write this, then this will give me how much? If I write this, how much this will give me? This will give me 32. This will give me 32 because there are 5 symbols here. Here you have 5 symbols. Here you have 5 space. So this will give me 32. Now I have 32. How much is remaining? Only 5 is remaining. Only 5 is remaining. So this 101 will give me 5. This 101, this will give me 5. Okay, so this I can say this will give me 5, and this you can put 0. Okay, very simple. So the final answer is basically 101 00101. This will be your binary. Is it clear? So whatever you have, you can just calculate. Very simply, you can calculate. Tell me what will be 520. What will be 520? What is the closest? The closest is 512. Closest is 512. That is 2 power 9. 2 power 9. So there will be 9 space. 4 space, 5 space. So total there will be 9 space. There will be 9 space. You will write like 9 space. And then how much is remaining? So this one has already given me 512. I already have 512. I only want 9. I only want 9. For 9, what I can do? I can write 8. This will give me 8. This will give me 8. And this will give me 1. Very simple. And the remaining things are 0, 0, 0, 0, 0, 0, 0. Because I already got my point. Okay, what I want, I got. Please let me know, did you understand? This method is very simple. Whatever you want, you can calculate. Okay, let's quickly calculate some of them. Oh, right. Oh, right. So, okay, so let me change the question. Okay, I have the pen. I can change the question. I'm not wrong. My answer is not wrong. The question is wrong. Okay, so anyway, so like this you can do. So is this clear? So very simple. So you can calculate all these things. You can very easily, you can calculate. Okay, so let's quickly do this. Let's quickly do this series like 40. Please tell me quickly 40. What will be 40? So 1 followed by 5 0. 1 followed by 5 0. Like, okay, this will give me 32. This will give me 32. I want 8. I want 8. And this will give me 8. This will give me 8. Okay, so the remaining will be 0 0. Let's find out 41. 41. Again the same thing. This will give me 32 because there are five space here. So this will give me 32, and this will give me 8, and this will give me 1. This will give me 1. Okay, so like this you can do. Very simple. Okay, so like this you can find the binary of any number, whatever number I ask you. Like 14, if I ask you for 14, what that will be? This will be 8. See, this will give me 8. This will give me 8 plus this will give me 8. How much I need? I need 6. I need 6. This will be your 6. I need 6. So this is very simple. So remember from one, okay, these things you should remember. All these things actually you should remember. Let me tell you one thing. I don't remember 13. Actually, what I remember, I remember from 1 to 8. I remember. Personally, I don't remember 13. So what I do, these are what I remember. Actually, personally, what I remember. Like, okay, what I remember. So let me tell you, I remember from 0 to 8. These I remember. Now I know that 8 is 100. I know this. Then how to calculate 9? I will just put only 1 is needed. Only 1 is needed. This is how, okay. So actually, this is my, I can say this is my milestone. So something like this. This is my milestone. So now from this I can calculate 9. Similarly, this is another milestone, that is 1010, because this is very cute. 10 is 10 is 1010. 10 is 1010. This is another milestone you can create. Another milestone you can create like this. 10 is basically 1010. Okay. Now, if you know that 10 is 1010, then what will be 11? Then just put one more. Just put one more. Just change it to 1. Just change it to 1. So this is your milestone, and now you can calculate. Another milestone you can create is 12. This 12 is another milestone because this is very cute, like another 1100. This you can create as another milestone. Now you can calculate 13. So the 13 will be plus 1. So the 13 will be like this. And the 14 will be what? 14 will be what? Now, okay, 14 will be 10. After 0, 1, you will get 10. After 0, 1, you get 10. And the 15 will be this. This is your another milestone. And 16 is very simple. 16 is extremely simple because this is power of 2. Okay, so now you can find 17. 17 will be 10001. From this you can calculate. So this is the complete study of binary and decimal number system. Please let me know, did you understand? Did you understand everything that we have seen so far? Binary number system, decimal number system. Okay, from where these weights are coming? Because let me tell you, many students, they do not understand. Like if in an interview, in some interview you are going to maybe IIT, ISC interview, some interview you are going, okay, and then someone will ask you from where these weights are coming. Okay, like why do we do the successive division? Why we write in the reverse order the remainders? The remainders we write in the reverse order when we convert decimal to binary. So to convert decimal to binary, we do the successive division. We find the quotient. So why do we find the quotient? Why do we do the successive division? Why we write in the reverse order? All these questions we have answered. Okay, every question. You don't have to by heart anything now. Okay. So if anyone has any doubt, you can ask. Please let me know. And this is the very quick method. From decimal to binary, from binary to decimal, how to go. Okay, how to go from one to another. This is the most quick method that I told you. Okay, very quick method. You can very easily find out the decimal, binary, all these things.